Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, chapter 4-5, linear automobile depreciation. Objective, write, interpret, and graph a straight line depreciation equation. So there's a few vocabulary words we'll go over first. Depreciate means to decrease in value over time. Appreciate means to increase in value over time. Generally speaking, cars depreciate unless there's some type of vintage collectible like a first-year Corvette or Camaro or any other like fancy car that people like to collect. They get higher, they appreciate, they increase in value over time, but most vehicles depreciate. Okay, straight line depreciation equation is the general form of the equation of a straight line is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, very simple concept from 8th grade in Algebra 1. The slope of the line is the numerical value of the inclination or declination of that line and is expressed as a ratio of the change in the vertical variable over the change in the horizontal variable. What? Change in y over change in x. y2 minus y1 over x2 minus x1. Remember that from algebra? All right, and from one point on the line to the next. Okay, so straight line depreciation equation is the general form of the equation of a straight line is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, oh, I got that twice. Why did I do that? Straight line depreciation and straight line depreciation equation. Okay, anyhow, expense function, a function that will indicate the cumulative amount of money spent at any given point in time. And then a variable expense. In the expense function, the fixed expense is the down payment, and the monthly payment that you make to the lending institution is the variable expense. It is the m in y equals mx plus b equation. All right, so we're going to get into that. We're going to try to determine when a vehicle's value is equal to how much you've invested as you've been making payments. That's kind of what this lesson is about. So let's jump right in. Okay, example 1 says, let me get my highlighter here. Suppose that you purchased a car for $27,000. According to your online research, this make and model of car loses all of its marketable value after 12 years. That is, it depreciates to a value of $0 12 years after the purchase date. If this car depreciates in a straight line form, what are the coordinates of the intercepts of the depreciation equation? Okay, so our y-axis in this case is here, and the x-axis is here. So this is car value in dollars, and this is years. Okay, so if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It said the car depreciates to 0 after 12 years. So year 12, boom, at 12, it is 0. The car's value is 27,000. So if I went 5, 10, 15, 20, 25,000 in thousands, okay, 25, 20, 15, 10, 5, then 27,000, let me do one more for 30. 27,000 would be approximately right here. So then if I were to take and draw a line segment from, let's do it in red, from this point here down to this point here, there is our straight line depreciation graph. Okay, so the car's value at year 0 when it was brand new was $27,000. This is the point 0, comma 27,000. Okay, and the car is getting depreciating. It's losing value, losing value, losing value until it got out to year 12 and it lost all of its value. So 12 years, x is 12. The value of it at that point is now 0. There are the 2 points on our graph that go from the starting value of the vehicle to the ending value of the vehicle. So it says, what are the coordinates of the intercepts of the depreciation equation? Well, one of them is 0, 27,000. Let me just draw circles around these. Here, let's just do this. So my 2 answers are right here and right here. Okay, 0, 27,000 and 12, 0. Okay, check your understanding. Now it says a car sells for D dollars and depreciates to a value of 0 after T years. If this car straight line depreciates, what are the coordinates of the intercepts of the straight line depreciation equation? So let me bring that graph in again. We should be using the graph each time to make it more comfortable to do or more understandable. Okay, so here's my graph. A car sells for D dollars. So this is the dollar value here. So somewhere around here, let's just call that D dollars. And it depreciates to a value of 0 after T years. So say that is right here. Okay, T, and this is years. Well, this would be T, and this would be D. Okay, so if I drew a straight line depreciation graph from here to there is what it would look like. Okay, and our coordinates are, this is over 0 up D, and this is over T up 0. So my answer is 0 comma D and T comma 0. Okay, so what we're going to do in this lesson is we're just doing bits and pieces and building up to learning how to do the 2 equations. And the next step is to find the slope between those 2. So it says to determine the slope of the straight line depreciation equation for the situation in example 1. So I go back to example 1 and it's 0, 27,000, 12, 0. So I'm going to write those 2 points down, 0, 27,000 and 12, 0. So I want to know what the slope is. Well, if this is x1 and this is y1, this is x from point 2, and this is the y from point 2, and my slope is y2 minus y1 divided by x2 minus x1. So that is going to become y2 minus y1 divided by x2 minus x1. So this is going to come out to be negative 27,000 divided by 12. So the slope of this line is negative 27,000 divided by 12 is negative 2,250. So what that means is that is the rate of this depreciation. So after every single year, if it was a linear equation where it is a constant rate of change, that would be depreciating $2,250 every year until it gets to 0 after year 12. Okay, so the slope is negative 2,250. Okay, so now check your understanding says, write the slope of the straight line depreciation equation that models the situation in which a car is purchased for D dollars. So if you remember from the last check your understanding, that was 0 D. And the total depreciation after T years was T comma 0. So if this was X1 and this is Y1 and this is X2 and this is Y2, then we would say M equals Y2 minus Y1 over X2 minus X1. Always write the formula first so you keep it fresh in your mind. So Y2 is 0 minus D over T minus 0. So in this situation, it was just going to be simply negative D divided by T. Okay. Okay, example 3 says to write a straight line depreciation equation for the situation discussed in examples 1 and 2, and then draw the graph of the equation. Well, I already drew it in discussing it with you, so I just brought that over here. Here's the equation. The car value started at $27,000 when it was new, and it was worth $0 after 12 years. And there's the straight line depreciation graph. So what's the equation of a line? The equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. So we calculated the slope in the last example, and the slope was negative 2,250. So that's my m. So it's negative 2,250 x plus y-intercept. And the y-intercept is the value of the car at its beginning value. So that is 27,000. So the equation is y equals negative 2,250 x plus $27,000. And there's the graph. All right, check your understanding says, write and graph the straight line depreciation equation for a car that was purchased for $22,000 and a total depreciation after 11 years. Okay, so let's do that. Okay, so the first thing we're going to do is I'm going to write m equals y2 minus y1 divided by x2 minus x1. And I'm going to write y equals mx plus b. So that is how I set this up. I need to find the slope that will go there. The y-intercept is the cost of the vehicle at the beginning, and that is 22,000. So I just need to find my slope. So it's going to be x plus $22,000. Okay. Starting value of the vehicle. So if I were up here, right here at $22,000, and it says after 11 years, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's 10, here's 11. Then I'd put a dot here. If it's a straight line depreciation, I would draw a straight line from the value of the vehicle when it was new down to $0 after 11 years. So there's the graph. Okay, very simple. And always label your graph, by the way. This is dollars, cost of value of vehicle, and this is time in years. I'll just put time, but it's time in years. Okay, so now I just need to find the slope of this line. So this is the point over 0 up 22,000. And this is the point over 11 up 0. So those are my 2 points I'm going to use. So let's call this x1, y1. I always label them from left to right. And this would be x sub 2, and this is y sub 2. So then I substitute in my equation. Y2 is 0 minus y1, which is 22,000, divided by x2, which is 11, minus x1, 0. So my slope is going to be negative 22,000 divided by 11. So my slope is going to equal negative 2,000, right? 22 divided by 11 is 2, and then bring down the 3 zeros. And therefore, I put that here, negative 2,000, and my equation is done. The equation is y equals negative 2,000x plus 22,000. Okay, example 4 says, suppose Jack purchased a car 5 years ago at a price of $27,600. According to research on this make and model, similar cars have straight line depreciation, 0 value, 12 years. How much will Jack's car be worth? Question is, how much will his car be worth after 66 months? Okay, so the first thing I need to do, or we need to do is find the slope, rate of change. And so the starting price, the point is going to be 0 years, $27,600. That's our first point. Okay, I don't like using commas in ordered pairs because there's 3 commas. It looks like it's XYZ. All right, so anyway, 0, 27,600. This is my X sub 1. This is my Y sub 1. My other point is going to be the value after 12 years. So that would be 12, 0. So there are our 2 points. This is X2 and this is Y2. So one point's the value of the car after year 0, and the other point is the value of the car after 12 years. Okay, so M is going to equal Y2 minus Y1 divided by X2 minus X1. So the slope is going to equal negative 27,600 divided by 12. And that's negative 2,300. That means the car depreciates $2,300 every year. 66 months. 60 months is 5 years. 72 months is 6 years. I need to convert this to months. So if it's losing $2,300 worth of value every year, then we need to convert this 66 months into years. So if I take 66 number of months divided by number of months in a year, that is going to equal, and if I take 66 divided by 12, I get 5.5. So it's 5.5 years. And we're talking about a graph in terms of years. So my equation is now going to be y equals mx plus b. And I came up with slope of negative 2,300, x plus the y-intercept's the value of the vehicle when it's new. So here's our equation, 2,300x plus 27,600. This is going to be my x, number of months, number of years, actually, 5.5 years. So it's going to be negative 2,300 times 5.5 plus 27,600. Okay, so the value of the car is going to be negative 2,300 times 5.5 is negative 12,650. Add that to the value of the car when it was new, 27,600. And that is the value of the car after that amount of time. Excuse me, $14,950. Okay, so the value of the vehicle after 5.5 years or 66 months is $14,950. Okay, check your understanding. Let's get my highlighter. A car sells for $18,495. It is a straight line depreciation to 0 after 9 years. Write the straight line depreciation equation for this car and an expression for the value of the car after W months. Okay, so first thing we're going to do is we're going to say M equals Y2 minus Y1. Let me scroll up a little bit here. Where's the bottom of that page? There we go. M equals Y2 minus Y1 divided by X2 minus X1. Okay, so what are our points? Well, car's value on year 0 is $18,495. So it's 0, 18,495. Okay, so that's one of the points, and that's x sub 1, y sub 1. And then we have the other point, straight line depreciation of $0 after 9 years, so 9, 0. So to find the slope, and this is my x2, and this is my y2. So it's y2 minus y1 divided by x2 minus x1. So my slope is going to be negative 18,495 over 9. And in this case, slope is rate of change. I keep saying slope, but it is a rate of change. So it's negative 18,495 divided by 9. So every year it drops $2,055. So there's my slope. Okay. So we have an equation here. We just found the slope of it, and we know the y-intercept. So y equals mx plus b. So if I just substitute in my y negative, or my m negative 2,055 x plus b, which is $18,495. This problem said to write the straight line depreciation equation and expression for the value of the car after W months. Okay, so here's the straight line depreciation equation right here. But now it says W months. Well, what did I have to do with the number of months up here? I had to divide it by 12 to get it. It's the W number of months divided by 12. So it's going to end up being y equals negative 2,055 times W divided by 12 plus $18,495. Okay, so you have to get the years into months by dividing by 12, and W is after W months. Okay, so there is the expression in terms of W months. Okay, on this question, it says a straight line depreciation equation for a car is y equals negative 4,000x plus $32,000. That means a car brand new was $32,000, and every year it dropped $4,000 in value. And that was a constant rate of depreciation, making a straight line. And so in approximately how many years will the car's value decrease by 25%? That is the question. So since the car is worth $32,000, what we want to know is if it decreases by 25% value, it is now worth 75%. Agreed? Take 25% away from the new car value and you're at 75% value. So the easiest way to do this is just take 0.75, which is 75%, and multiply it by 32,000. And that will give me 0.75 times 32,000, and I get $24,000. So what this question is asking is approximately how many years will the car's value decrease to $24,000? So let me bring a graph over so I can show you a picture of this as we're doing. Okay, so this is the value of the car over here, and this is my y-axis, and this is my x-axis, and this is the time in years. Okay, so there's my graph. So what they're saying is that the car is right here, and it was worth $32,000. And it straight line depreciates after, what was it? We don't know. They didn't give us the amount of time it straight line depreciates to 0. So let me just put a point over here somewhere, and that's some time t. And if I draw a straight line, because it's a straight line depreciation, then it would be a line going from here straight down to here. So what they're asking in this problem is, if 24,000 is right here then that would be there. We want to find out how long, what time did that occur? Does that make sense? With the picture, hopefully. So what we're going to do now is, okay, $24,000. That is our Y, guys. This is our value, our Y value in our equation. So write Y equals negative 4,000x plus 32,000. And we're going to substitute this 24 in for our Y. So $24,000 equals negative 4,000x plus $32,000. Subtract 32,000 from both sides. And I'm going to get 24 minus 32 is negative $8,000 equals negative $4,000. X. Get X by itself, we divide by negative 4,000 on both sides. And we're going to get X equals 2. So approximately 2 years, this car will be worth $24,000. Okay. Okay, to check your understanding says write an algebraic expression that represents the length of time it will take the car in example 5 to have a value of D dollars. Okay, so we don't want to write the equation. We don't want to write Y equals mx plus b. That is an equation. We just simply want an expression. So how did we solve this problem? We took the depreciation value and we subtracted the car's value. So example 5, when will it have a value of D dollars? So here we're trying to determine when it had a value of 24,000. So we're going to take this right here and subtract. So now it's D instead of 24,000. So it's going to be D minus the value of the car, and it's when it was new. And then what did we do? We divided it by our rate of change, which was $4,000 negative. Okay, so there's our expression. Some dollar value minus the car's initial value divided by the rate of change, which was negative 4,000. And that is the expression in terms of D. Okay, example 6 says Celine bought a new car for $33,600. Okay, new price. She made a $4,000 down payment and pays $560 per month for 5 years. She knows from her research that the make and model of the car she purchased straight line depreciates to 0 over 10 years. Create an expense and depreciation function. Okay, so let's start with the expense function. And remember, Y equals mx plus b, where m equals y2 minus y1 divided by x2 minus x1. Okay, the expense function is simply, actually, I don't need to do that for this. I'll leave this here for the next one though. Let's move this over. That is going to be for my depreciation equation. In this one, the down payment is our y-intercept. So if this was 5,000 right here, and this is dollars, then 4,000 would be right here. You're starting out, you paid $4,000. How much more do you owe? The car is $33,600. So here's 10, 15, 20, 25, 30, 35 up here. So 33.6 would be somewhere around here. Okay, I'm up a little too high here, but that's okay. That's fine. Right there, that is $33,600. The cost of the car when it is new is right there on the y-axis. And here's my x-axis, and that is time. Okay, so at time 0, she paid $5,000. Here's 5,000. She paid 4,000, which is down here just below 5. So 4,000 is the y-intercept. So if I have the equation y equals mx plus b, the b in my case here, or in her case, is, $4,000. Okay, the starting value that she put down on the car. The slope or the rate of change is how much she pays each month, which is $560. So that is going to be 560 times the number of months X, and there is my equation. So there's the expense equation. The depreciation function we have to do as an ordered pair. Remember, this is the point 0, comma 33,600. Again, I don't like commas with ordered pairs. And it's going to depreciate to 0 over 10 years. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right here. So a depreciation graph is going to look like this, starting here and depreciating to 0 after 10 years. Okay. So this is the point 10, comma 0. So my slope, now I'm going to do my slope here. Y2 is 0 minus the cost of the car, which is Y1, $33,600, divided by X2 minus X1. So my slope or rate of change is going to be negative $33,600 over 10. So getting rid of one of the zeros, we're done. So the slope is negative $3,360. So now I can write Y equals negative 3,360X plus the cost of the car when it was new, which was 33,600. Okay, so this is the equation of the depreciation function. Okay, so there's those two. Let me change the color of one of them. Okay, so I just changed this all to red so that you see the depreciation is in red going down. And now I want to do an appreciation. Who do we appreciate? Starting at 4,000 going up and over, slope of 560. Well, we got to find a point where that's going to cross. And so we need to make some changes. Since this is in months, this needs to get changed to months. So let me change that to months right here. That's all we would need to do. So 10 years is 120 months. Okay, 110, here's 100. 90, 80, 70, 60, 50, 40, 30, 20. Did I do that right? Let me count these out better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's 120 months minus 12 months. That's what I'm doing wrong. Minus 24 months and so on. So let me redo these marks and let's go out 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and make that 120. Okay, so these are in tens, 10 months, 20 months, 30 months, and so on. All right, so once that's done, time in months. Okay, so what we need to do now is determine where they're going to cross. We do know the slope. So it says to graph them on the same axis, starting at 0, 4,000. And this is, if I go over 10, if the rate of change is 560 per month, it's going to be 5,600 per 10 months. So 4,000 plus 5,600 is 9,600, which would be about here. Okay, and it would continue up at that rate. So let me now just draw a line. Okay, so it would be from here going up like so. And the value where they intersect is where the value of the vehicle meets the amount we owe. So then C says interpret the region before, at, and after the intersection points. Well, if I'm before the intersection point, like right here, the amount I've paid for the vehicle is less than the amount it's worth. Does that make sense? When I get here, the amount I've paid for the vehicle is equal to the amount it's worth. And now that I'm up here, if I were up here, the amount I've paid is more than what the car is worth. So if it takes me too long to purchase a vehicle, it takes me too long to pay for it, there's going to come a point where the car is worth less than what I owe. And that's never a good thing. That's called paying on a dead horse. All right, so check your understanding. How might the expense function be altered so that it reflects a more accurate amount spent over time? What effect might that have on the graphs? Okay, this is a fairly lengthy answer. You can include your monthly maintenance and insurance costs with the monthly payment amount. With this will yield a slope that is greater than the one depicted in the graph. Since the expense graph will be steeper, the intersection point will have an X value that is less than 35.24. This will indicate that the value of the car will be less than the expenses to date earlier in the car's lifetime. Okay. All right, calculating all the other expenses. All right, example 7 is a little bit complex. It's a little challenging. So let me try to explain what is going on here. It says, suppose your car straight line depreciates monthly over time. They didn't tell us what the car is worth. It says that after 12 months, the car is $24,600. And according to an online car value calculator, after 23 months, it'll be worth $21,850. How much does the car depreciate each month? So if it's a straight line depreciation, it will eventually get to 0. So let me just graph this for you, just to give you an idea as to what we're talking about here. So here would be the straight line depreciation down to 0. And they're telling us that after 12 months, the car is worth $24,600. So if I went up here and just picked this point here and said that was $24,600, okay, after 12 months or 1 year, there's the value of the car. And then it says, according to an online car value calculator, after 23 months, so if this was 24, just a little to the left of it, we'd go up and we'd put a dot right there. And then we'd come over here and put the value, and they said it was worth $21,850 at that time. Okay, so there are our two values. There's a couple of ways we could do this. I could actually do the slope intercept and find the rate of change that way. But this problem was asking us to do it a different way in the book, and it explains what's called an arithmetic sequence. And an arithmetic sequence is you take a sequence, a sub n is an nth term, that's depending on how many terms are in a sequence, and it equals, let me first, it's the first term, a sub 1, and it's plus number of terms minus 1 times d, which is a common difference. So that is the formula for an arithmetic sequence. Okay, so in this situation, we have for n equals 12, for n equals 12, that's a sub 12. Okay, so that'd be a sub 12, right? When n equals 12, number of months, n. If a sub 12, well, a sub 1 is an unknown. We don't know it. We don't know what the car was worth at the beginning. We could calculate it, but we're going to do it this way. And it's going to be plus n minus 1. Well, n is 12 in this case, minus 1 times d. And that's basically all we can do right now. I can simplify that and say that a sub 12 equals the first term, a sub 1 plus, and simplify this down to 11. 12 minus 1 is 11d. And if I do that again for a sub 23, then it'd be n equals 23. So I'm just going to repeat this in a different color. N equals 23. Then we would have a sub 23 equals the first term plus n minus 1. Well, rather than writing the formula, let me just put the value in. N 23 minus 1 times d. So simplifying that, we're going to get a sub 23 equals the first term plus 23 minus 1 is 22d. Okay, So once we've done that, we then plug in our values. And at A sub 12, after the 12th month, let me do that in black, after the 12th month, it's worth 24,600, and that's our A sub 12. So now I substitute in $24,600 equals A sub 1 plus 11D. And then over in this one, after 23 months, it's worth this. So I'm going to put 21,850 for A sub 23. Still don't know the first term, and we don't know the common difference of D. So there are our two formulas. And what we're going to do is we're going to subtract one from the other and solve, because A is going to cancel if we subtract. Okay, so hopefully that makes sense to you. If I take 24,600 equals A sub 1 plus 11D, and I subtract the equation 21,850 equals A sub 1 plus 22D, and I subtract these, I'm going to get A to go away, A sub 1. So 24,600 minus 21,850, 0 minus 0 is 0. I need to borrow from this. 10 minus 5 is 5. I need to borrow from the 4 now, 7, and 3 minus 1 is 2. And I get A sub 1 minus A sub 1 is nothing, and 11D minus 22D is negative 11D. Divide both sides by negative 11, and we find D. So 2,750 divided by 11 is 250. So that's our common difference. Okay? And it's negative. All right. Because that was a negative 11. So 27 divided, a positive divided by a negative is negative. So D is negative 250. So it says, how much does the car depreciate each month? It depreciates $250 a month. And there you have it. I could have also done it with these 2 points, 12, 24,600 and 24, 21,850. Found the slope, determine the y-intercept with that slope, and then calculate what it would be, how much it changed between these two distances. But this way is actually easier. Okay, so now the check your understanding says a car straight line depreciates monthly over time. After 8 months, the car is worth 29,520, and after 18 months, it's worth 26,420. How much does this car depreciate each month? So that's going to be the same type of problem. So let's try it. Okay, so let's just do this. And I'll start with the formula. Arithmetic sequence, A sub n equals A sub 1, which means our first term, plus number of terms minus 1 times the common difference D. All right, so after 8 months, that's A sub 8 equals A sub 1 plus 8 minus 1 D. After 8 months, the car is worth 29,520. That's our A sub 8. So I put 29,520 equals A sub 1 plus 8 minus 1, which is 7D. Okay, do the same for the other one. So in this case, we have an A sub 18 equals A sub 1 plus 18 minus 1 times D, and my A sub 18 is 26,420. So I substitute that in and get A sub 1 plus 17D. Okay, so now I'm going to take this and subtract this. So it's 29,520 equals A sub 1 plus 7D minus 26,420 equals A sub 1 plus 17D. Okay, so I'm going to subtract these two. 29,520 minus 26,420 is 0,013. 3,100. A minus A is 0. It cancels. 7 minus 17 is a negative 10D. Divide both sides by negative 10. And I get D equals negative $310. Okay, so the car depreciates $310 per month. Okay, and that is the end of chapter. What was it? Chapter, forgot what chapter we're in, 4.5. That's the end of chapter 4.5. Thanks for watching. Have a great day and peace.